Hi again, Dr. P here, and we're moving on into Chapter 24, Amines. And in this lecture, I will talk about what amines are, give a little introduction, and go over their nomenclature, and also talk some about their structure. So let's start with an intro to amines. So amines are organic derivatives of ammonia. And that is, they have one or more alkyl or aryl groups bonded to nitrogen. And we have many important amines found in biology, many biologically important amines. These include things such as neurotransmitters, some defensive substances, and these could be things such as alkaloids or other substances. I'll just say other poisons. There are vitamins that are amines. In fact, the word vitamin is short for vital amine because it was believed at the time that all vitamins contained amines. Many of them do. It's not the case that all of them do. So that's where the word vitamin came from. Some hormones, and a bunch of other stuff as well. Okay, so let's take a look then at some amines here. And should I call this types or classification? Let's call it classification of amines. Okay, now of course if we have NH3, that is simply ammonia. Scoot that over there. If we have one alkyl or aryl substituent, we would call this a primary amine. If we had two alkyl or aryl substituents, and I'll indicate these differently, R and R prime, because they don't have to be the same. That is a secondary amine. You could have R, N, R prime, R double prime. That would be a tertiary amine. And then lastly, we could have R, N, R prime, R double prime, and R triple prime with a positive charge. And we call that a quaternary ammonium salt. Or it's a quaternary ammonium, I should say ammonium ion. It's a salt when you have a counter ion. Okay, so these are how we would classify them. And notice that they're different than how we classify, for example, primary, secondary, tertiary alcohols, or primary, secondary, and tertiary alkyl halides. There we're looking at how many alkyl chains are attached to the carbon that the oxygen or the halide is attached to. Here it's actually how many alkyl chains are directly attached to the nitrogen. Okay. Now let's look at some naming of some amines. So it'd be helpful to know what we're talking about before we start talking about it. So we do have common names. Where we'll name the alkyl group and then add amine. So for example, if I had CH3, CH2, NH2, let's see here. This here, of course, is an ethyl group. So this becomes ethylamine. We could have, let's say, multiple groups. So let's say we had CH3 and CH3H, like so. I've got two methyl groups, so that would be dimethylamine. They could be different groups. I could have a methyl and an ethyl, ethyl-methylamine. I could have a butyl and an isopropyl. There's a variety of things that you could have. Naming it with the IUPAC name so for the IUPAC names, we're going to name it as the parent alkane, so the longest alkane chain that the amino group is attached to. Oh yeah, I should mention that an NH2 group is an amino group. NH2 is amino group. So just like, you know, for alcohols, the OH group is the hydroxy group, and so here the NH2 group is the amino group. So whatever our amino group is attached to, whatever the longest chain is, we'll use that parent alkane name. And we'll name it as an alkanamine. Whoops, let me write this down here. A-L-K-A-N-A-M-I-N-E. So, let's say name as alkanamine. So now our ethylamine would become ethanamine. And dimethylamine would be N-methyl-methanamine. And notice the N here, that indicates, this indicates substituent attached to nitrogen. Now there are other common names. So for example, some of the aromatic amines are derivatives of aniline, which we would also call aminobenzene. So if I had something like that, where I've got two methyl groups attached to the nitrogen of aniline, I would call this NN dimethyl aniline. Okay, so yeah, there's people use the common names pretty frequently. I mean, people don't necessarily call it N-methyl-methanamine. It's easier to say dimethylamine a lot of the time. But something like NN-dimethyl-aniline is definitely, you definitely run into that a bunch. All right. I do want to give you guys a little heads up here. Later on in the lecture video, I will mention some nitrogen heterocycles. which are cyclic amines. So these could be things like pyrrole. Let's see here. Imidazole. Oh, there's some other good ones here. If any of you were in the section that this year being 2024, had presentation on serotonin, we see that serotonin and tryptophan are derivatives of indole. We can also find things like, so now we're getting into aromatic heterocycles here. Actually, all these guys are aromatic heterocycles. This is pyridine. Let's see here. Let's do piperidine, P-I-P-E-R-I-D-I-N-E. And then just a couple more that I want to mention here, and I'll talk more about these in a later lecture. It's a little sloppy there, sorry about that. This is pyrimidine, and then purine. And you may remember pyrimidine and purine as being the things that pyrimidines and purines are built up from in DNA bases. Okay, remember the bases, we have the pyrimidines, adenine, thymine, and we've got the, I'm sorry, adenine's a purine. Anyway, strike that, never mind. Pyrimidines such as uracil and thymine and cytosine, and then pyrimidines like adenine and guanine. Sorry about that. Sorry about that. Anyway, it's late. What can I say? So we run into these types of amines quite a lot, really in biological systems. Imidazole is the side chain of the amino acid histidine. Indole is found in tryptophan, and then of course pyrimidine and purine are bases. And I realized something here. I realized I misspelled pyrrole. That was looking wrong to me. P-Y-R-R-O-L-E. 2 R's, 1 L. 1 L. Sorry about that. All right. So the last thing I really want to talk about here is some structure. So now, of course, we have tetrahedral electron geometry. And trigonal, pyramidal, molecular geometry. So just for example, looking at ammonia, well, no, let's look at methylamine, or let's just say any primary amine. So I'll have R, N, coming out towards us, there'll be a hydrogen. Going away from us is another hydrogen. And then here is my lone pair. And so overall, my shape is tetrahedral. My geometry is tetrahedral, including the lone pair. But if I ignore my lone pair, the shape of my molecule is, let me ignore the lone pair that way so you can see the H's. I've got my little trigonal pyramid. Now I should note that this structure is not fixed. So what we can actually get is inversion like so. And it may be a little bit hard to see this, so I actually I did print out a copy of a page from the text. If you want to see this in color, you can go ahead and check that out, page 866. And just to zoom in, let me zoom in a little here. There we go, there we go, there we go. All right. So we can see that we've got here our tetrahedral overall shape, including the lone pair. This lone pair is in an sp3 orbital. Now it can actually undergo inversion, where basically it's flipping like an umbrella turning inside out. And I know it seems a little weird, but the way it works is it goes through an sp2 hybridized state, which is planar, where we've got the lone pair in a p orbital on both sides there. And then it flips over to the other side, and we now have back to sp3 hybridization, and our lone pair is now on the other side. So amines, with the exception of certain situations, amines are actually not going to be chiral because you get this inversion. And as the text mentions, the barrier to the inversion is about twice as large as the barrier to rotation about a carbon-carbon single bond. So it's really not that difficult to do. Okay, so I did want to mention inversion. So let me just show you what that will end up looking like when it comes time to, let's see, am I there? Yeah, I think that's good there. I think that's good. Yeah, that's good. All right. So if I had methyl ethyl propylamine, that would not be chiral. Even though looking at the nitrogen here, I know this nitrogen is tetrahedral, and it has technically 4 different things on it. It's got a methyl group, an ethyl group, a propyl group, and a lone pair. But the thing is, it rapidly interconverts, it rapidly inverts from one to the other. So it ends up being not chiral. But if we had a situation, so let's take the following situation. So let's see here. Let me put my nitrogen, let's go ahead and maybe put this in some kind of a ring here. And let's see here. Let's go ahead and fuse this ring. Let's see how I would do this. I'm just trying to think. So basically, for an amine to be chiral, either a carbon would have to be chiral in the molecule, or we could have a quaternary ammonium salt with 4 different alkyl groups on it, or, and this is what I'm trying to draw, we have a structure where we can't get to that, we can't get to, oh, you know, let me do it this way, hold on. We can't get to, and let's see, let's stick a double bond right there. There we go. Is carbon. Okay, so this guy can invert. This nitrogen here has 4 different things. It's got the carbon that's double bonded to another carbon, a carbon, a CH2 that's bonded to another bridgehead, and then a CH2 then bonded to the bridgehead. So those are 3 different things, plus the lone pair is 4 things. And that's because it cannot invert. So the amine that is not chiral, even though it's got 4 different things, can invert. The chiral amine has 4 different things, and it cannot invert just by geometry. Okay, we just can't get this guy to invert because the alkyl groups are all attached at the other side, so they'd have to come undone and stuff. Anyway, you get the general idea. All right, so that is a little introduction to amines and some nomenclature, a little bit about structure. I'll talk some more about properties, especially basicity, in the next lecture. So until then, stay safe out there. Bye now.